In this discussion video, we'll do some examples where we find the volume of a solid when given its base and cross-sections. So this is problem 11 from worksheet 15, and it says, consider the region bounded by the x-axis, x equals 2 and y equals x squared. I want to look at C and D. C says, imagine the solid created by this region as a flat base, where cross-sections parallel to the y-axis are squares. What is the volume of the solid? And D says something very similar, except the cross-sections are parallel now to the x-axis. Okay, so before I give you a chance to pause it and try it, let's draw a picture of this region. Okay, so I'm going to draw some axes. So I'll have my x-axis and my y-axis. Okay, so it talks about the x-axis will bound the region. The line x equals 2. So x equals 2 and the curve, the parabola y equals x squared. Okay, I've deliberately just drawn most of the parabola in the first quadrant because I knew ahead of time that this region would be bound. The region that's bounded occurs in the first quadrant. Okay, so from here, I want to give you an opportunity to try the problem. Pause the video for 3 minutes. First thing that you'll probably want to try to do is draw these cross sections the problem's talking about. All right, so I'm going to give you a chance to try it. Pause the video for 3 minutes. In 4, 3, 2, 1, pause it and try it for 3 minutes. All right, so hopefully you did that. Hopefully you paused it and tried it for about 3 minutes. If not, definitely go ahead and do that now. That's going to be super important. Okay, let's talk about it. All right, so when it says that this region is a flat base, it means that this region here is the bottom of this 3D shape. Okay, and then it describes the cross sections. It says that they're parallel to the y-axis. So they are gonna, so the ones I'm gonna draw are the ones that are parallel to the y-axis. They will be straight vertical up, down like this. And they're gonna be squares. Okay, so if I, form this would be the bottom of my cross section. It's lying on this region. That would be the bottom of a square. This cross section is supposed to be a square. Okay, and then to make it 3D, I need to have this sort of come out of the page. So I'm gonna draw the lengths that come out of the page slanted. Hopefully that looks a little bit more 3D. We got to kind of use our imagination here a little bit. Okay, I'm going to draw one other of these cross sections, maybe a smaller one. So I'll draw one of these lines here. That would be the bottom of my square. I draw some slanted lines to indicate, oh, it's coming out of the page. And then there's the top of the square. And these cross sections have a little bit of thickness. So these have a little bit of thickness in the x direction. So I'm going to call that dx. Okay, so if I think about my formula for volume, it is, I'll have the integral. This is going to be a dx integral because my thickness is in the x direction. So then I write my area, but my area is going to be a function of x because this is a dx integral. Okay, and then for the limits, they're in terms of x. The smallest x ever gets in this region is 0, and the biggest it ever gets is 2. Okay, so I have volume equals integral from 0 to 2. And I need the formula for the area of this cross section. Well, the cross section is a square. So I'm going to call this length S. And this length S, the sides of the square are all the same. And the formula for area of a square is just S squared. Okay, but I can't take the antiderivative of this because the variables are different. This is an S and that's an X. Okay, so I need to figure out, well, what is S in terms of X? So if I look at this coordinate here and I call it X comma Y, my S, this length of the square depends on that y coordinate. So S is equal to y. I can't plug that in yet because then the variables are still off. I'll have y and x. Okay, so here's what we'll do. This is x comma, and I'm going to use my equation for that curve. I know y is equal to x squared. So the y value is equal to x squared. So that's what this y is going to be equal to, x squared. And that is what we're going to plug in for the s. So this will be the integral from 0 to 2. S is x squared, and that will be getting squared dx. All right, so we have the integral from 0 to 2. All right, function is x to the 4 now, dx. That antiderivative will be x to the 5 over 5 with some reverse power rule. I got to plug in the 0 and the 2. If I plug in 2, we'll get 32 over 5. Minus, if I plug in 0, we'll get 0. So my answer is 32 over 5. Okay. All right, so part D now says, well, do the same thing. but now make the cross sections be parallel to the x-axis instead. All right, so for this one, I want to first give you 4 minutes to try it without me drawing anything this time. So pause it in 4, 3, 2, 1, pause it and try it for 4 minutes first. All right, so hopefully you did that. Hopefully you paused it and tried it for about 4 minutes. Let's talk about it. So I'm going to draw a picture. So we'll have our axes. Then we have this parabola shape. We have that line at x equals 2. That line at x equals 2. So we have this region, which is the base or the bottom of this solid. That's what the problem says. But now it says that the cross sections that are parallel to the x-axis, so that means they're going to be horizontal, are going to be square still. It's just we're now looking at them parallel to the x-axis. Okay, so I'm going to draw the bottom of one of these squares. So there we go. Okay, so that's going to be the side of one of the squares. And now I'm going to draw lines to sort of indicate, oh, it's going to come out of the page, this square. So I'll draw a slanted line. Gotta use my imagination, you know, to think, oh yeah, it's coming out of the page here. Okay, I'll give it a little bit of thickness now. Okay, a little bit of thickness here. So that thickness is now going in the y direction. This is going to be a dy. Let me draw one more of these cross sections, one of the smaller ones. So if I were to draw something like here for the bottom of the square, then some slanted lines coming out of the page, and then the top of the square, I get something like this. Alrighty, so if I use my formula for volume, it'll be the integral. This time it'll be dy. So my area function, I have to now write in terms of y. And my y values for this kind of base region, they start at 0, and they go until the coordinates at this point. I know the x coordinate's 2, and if I plug that into y equals x squared, my parabola equation, we'll get the y values 4. Okay, so the upper limit is 4. That's what the y values go up until. All right, so I get the integral from 0 to 4. The area of this cross section, this square, let's see if I call this s. The side length, and this is s as well. The area of a square is just s squared. And then I have dy. I still can't take the antiderivative yet because these variables are different. I need y's here, not s's. Okay, so we have this integral from 0 to 4. I need to know what is s going to be in terms of the variable y. So if we look at our picture, s is kind of determined by this point and this point. Specifically, I know the x coordinate of this point is 2. I don't know the y coordinate, so let me just call it y. Okay, what I'm going to try to do now is I'm going to label this point also. It's going to have the same y coordinate, so I'll keep calling it y. But the x coordinate, I don't know. I'm just going to call it x. Because now s, that length from here to here, is just the bigger x coordinate minus the smaller x coordinate. It's going to be 2 minus x. Okay, I can't plug that in because the variables will still be off. I need to plug in for what x equals. And if we use our equation, this y equals x squared, I need to isolate the x. So that would give me x equals root y, but I'd get a plus or minus because I even rooted. So what's the difference? If I had x equals positive root y, when I square root something, the output is non-negative. So this would be saying x is non-negative. So that would just be the right half of this parabola. Whereas if I had x equals negative root y, now my outputs, because of that negative sign, are going to be non-positive. So that would be the left half of this parabola. And in my picture, we're using the right half of the parabola. So we're going to be using this thing. So s is going to be equal to 2 minus the x value is root y. So let's plug that in, 2 minus root y. Okay, so from there, I get integral from 0 to 4. I could expand this to get 4 minus 4 root y, which is 4y to the 1/2. And then I'll get plus y for the last term. From here, we'd be ready to do the antiderivative and plug in and simplify. I'm going to just put dot, dot, dot. And I'll leave that for you. And I'll just tell you what you get at the end, which is going to be 8/3. And that's our answer.